Assalamualaikum warahmatullahi wabarakatuh. Let me introduce myself. My name is Dwi Rara Rahmiati and I'm from Group 1. Today I would like to give you a presentation about algebraic equation. Okay, the first one is vocabulary, and the first vocabulary is algebra. Algebra is a part of mathematics that help represent problem or situation in the form of mathematic expression. Example is 3a plus 14. Example, -1. Alright, the second vocabulary is coefficient. Coefficient is a numerical or constant quantity placed before multiplying the variable in an algebraic expression. Example is 2x. 2 is a coefficient of x. Then, the third vocabulary is function. Function in mathematics is an expression, rule, or law that defines a relationship between one variable, the independent variable, and another variable, the dependent variable. Example is y equals x plus 1. Then, the fourth vocabulary is greater than. Greater than show that one number of value is larger than another number. Example is 4 greater than 3. Alright, the fifth vocabulary is greater than or equal to. Greater than or equal to states that the number or value is either equal or more than the given limit. Example is x greater than or equal to 1. Alright, the sixth vocabulary is less than. Less than states that the number or value has to have a value lesser than the given limit. Example is x less than 5. Next, the seventh vocabulary is term. Term in algebra is defined as the value on which mathematical operation occur is an algebraic expression. Example is math term of geometry is circle, triangle, and other. Then we move to the eighth vocabulary is factorization. Factorization is when you break a number down into smaller number that multiply together into smaller number. Give you the original number. Example, 2x plus 6 equal 2x plus 3. The ninth vocabulary is digit. Digit are single number used to represent value in math. Every digit in a number has a place value. Place value can be defined as the value represented by digit in a number on a basis it is of its position in the number. Example, 1, 2, 3. And the last vocabulary is number. Number form the basic of mathematics. Numbers are used for counting, measuring, keep things in order, indexing, and other. Number have different type of number based on properties. Example is 1, 2, 3. Alright, we move to video, and I will re-explanation from the video sample question. We have 3x plus 5 equals 17. So let's say 3x is x, and 5 is in 5 objects. So we can say O plus O plus O plus O and plus O. X plus X plus X plus O plus O plus O plus O is 17 times, and we subtract 5 objects on the both sides, so that the result becomes 3x plus 5 equals 17. Subtract 5 on both sides, so the result is 3x equals 12. Divide both sides by 3, so x equals 4. Say again with a different question, and 7x minus 2 equals -10, so the result is 7x equals -8. Divide both sides by 7, so we have x equals -8 per 7. We move to the example question, and example 7. Alison and Russell were competing in a race. Alison had a 10-minute head start, was running at 3 km per hour. Russell ran at 5 km per hour. And how many times did Russell catch up with Alison? And the answer, we need to know. 1. Distance traveled by Alison equal distance traveled by Russell. 2. Distance equal rate times time. We'll represent time by t. 3. Alison ran 10 minutes more than Russell. 4. Alison ran 3 km per hour. 5. Russell ran 5 km per hour. 2. In how minutes did Russell catch up with Alison? Distance traveled by Alison equal distance traveled by Russell. Rate Alison times time Alison equal rate Russell times time Russell. And we have 3 per 60 times t plus 10 equals 5 per 60 times t. 3t per 60 plus 30 per 60 equals 5t per 60. 3t plus 30 equals 4t. I'm sorry, I mean 5-3. Then 30 equals 5t minus 3t. Then 30 equals to t, and we have t equals 15. We have to prove distance traveled by Alison equals rate times time equals 3 per 60 times 15 plus 10 equals 3t per 60 times 25 equals 1.25 km. Distance traveled by Russell equals rate x time equals 5 per 60 times 15 equals 1.25 km. The conclusion, Russell catch up with Alison in a race after 15 minutes. Then we move to the example 8. If Joe can paint 5 rooms in 8 hours and Samantha can paint 3 rooms in 6 hours, how long will it take them to paint 7 rooms working together? The answer, first we have to know that we can use formula rate. Rate is number of jobs complete per time. 2. Using rate formula, we can see Joe rate and Samantha rate. Joe's rate equals 5 rooms per 8 hours. So 5 per 8 hour. 5 per 8 rooms per hour. That was the Joe's rate. So Samantha rate is 3 rooms per 6 hours. So we have a half room per hour. Third, how long to paint 7 rooms working together? Let t equals time to complete the job together. So 7 room paint equals room paint by Joe plus room paint by Samantha equals 5 per 8 plus half times t. 5 per 8 plus 4 per 8 times t equals 9 per 8 times t equal 9 per 8 times t. 7 times 8 equals 90. 56 equals 90. 56 per 9 equals t. T equals 6 2 per 9 hour. The conclusion is Joe and Samantha need 6 times 2 per 9 to paint 7 rooms with working together. We move to the examples 9. It takes Susan 10 hours longer than Lowry to take their store's inventory. If it takes 3 per 4 hours for them to do the job together, how long would it take Susan to do it alone? Answer, since Lowry takes less time to complete the job, we'll let her time be represented by t. If we can find this time, the answer to the problem will be t plus 10. The number of jobs considered if in the problem is 1. Therefore, Lowry's rate is 1 per t, and Susan's rate is 1 per t plus 10. 40 times t plus 10 equals 15t plus 15 times t plus 10, and 40 to the power of 2 plus 40t equals 30t plus 150. 40 to the power of 2 plus 10t minus 150 equals 0. 2t to the power of 2 plus 5t minus 75 equals 0. So we have 2t plus 15 times t minus 5 equals 0. 2t plus 15 equals 0, or t minus 5 equals 0. So we have t equals minus 7.5, or t equals 5. Since the problem requires physical time, we reject the negative answer, and we see that t equals 5 is lowest time. Therefore, Susan can complete the job in 15 hours working alone. And one job is equals amount done by Susan plus amount done by Allison. Using the 15 per 4 for 33 per 4, the amount done by Susan is 1 per t plus 10 times 15 per 4, and the amount done by Lori is 1 per t times 15 per 4. Substituting into the Freding model, so we have 1 equals 1 per t plus 10 times 15 per 4 plus 1 per t times 15 per 4. So we have 4 per 15 equals 1 per t plus 10 plus 1 per 10. After multiplying both sides, then by the least common denominator, 15t times t plus 10 we get. Move to the example 10. At the chocolate factory, John's job to experiment with mixing different amounts of milk and chocolate to find different flavor. If he mixed 2 quarts of type A with contain 15% chocolate with 1 quart of type B which contain 10% chocolate, he created type C. What percent of type C is chocolate? Answer: in a situation like one above, we can see that the three types of relationship, namely type of chocolate equals what percent of chocolate times number of types of chocolate be the first. In the type A, we have 15% chocolate, or 15 per 100 chocolate. Then we change the denominator to 0.15. 0.15 times 2, so we got 0.3 quart. In the type B, we have 10% chocolate, or 10 per 100 chocolate. Then we change to 0.10, then 0.10 plus 1 equal 0.1 quart. Then after we know, then we'll calculate how much percentage of the chocolate after we add together type A chocolate and type B chocolate. Then we mixture of type C chocolate. We'll use the formula amount of chocolate per amount of type equals percentage of chocolate. 1.3 quart plus 1.1 quart per 3 equals 1.4 quart per 3 equals 1.1333. So we can round the percent to be 13.3% of type. So type C has a 13.3% chocolate. Okay, I think that's all for me. Thank you so much for your attention, and Assalamualaikum warahmatullahi wabarakatuh.